Yeah, so like I mentioned, we're going to put StyleGAN aside for a little bit, and we are going to jump and look at a couple different other models. So as I mentioned in the previous part of class, like we're going to look at style transfer. So today I'm going to walk you through how style transfer works. This particular one I have a Collab notebook for. And if you're interested, like maybe depending on how much time we have at the end of class, like I could actually walk us through the Collab notebook. I know that some of us have started working on the Collab stuff for StyleGAN, but if you're really interested, like one of the things that's really nice about Collab is it's free, so therefore it's like you don't have to worry about like spending lots of time and breaking stuff in there because it is free. And actually, while I'm talking about that, I'm going to be teaching there's going to be a live stream Friday at noon. That is, I'm going to do just about Collab in general. So if you are around and interested, you can watch that. It'll be recorded otherwise, so you can watch it whenever you want. But if you are around and are bored during a Friday lunch, like feel free to join me. I'll post the link to the YouTube in Slack if people are interested. But basically, like Collab is great because Collab is free. The downside to Collab is that there's a time limit to how long you can use it for in every session. So for something like style transfer, where it takes about 10 images to produce, or 10 minutes to produce an image, it's totally good and it's perfect for that time. In the case of StyleGAN, where you saw that it takes us, you know, hours, days, months to train a StyleGAN model, you can't really do training in that way inside of Collab because of those limits. There are people who will like train a model for 8 hours, stop it, restart it, train again for 8 hours, and do that over and over again. I find that to be super tedious, and like it often doesn't work the way you expect it to. So you could do that, and there are people who try that, trying to use the free option of Collab to do that. But I personally, like, unless you're really trying to do everything for free, I wouldn't recommend it, but that's an option. So we'll go through style transfer. I might look at the Collab notebook for that together with us. And then I'm also going to do next stream prediction. And next stream prediction, similar to StyleGAN, takes a little while to train. It takes probably a day or two. So there again, I wouldn't necessarily recommend Collab for that. And I would just look at doing this on Paperspace. So I'll walk us through both of those models. And then we'll see how much time we have left at the end of class, and we can decide if we want to talk about questions or if we want to look at other things. So I will walk through that. Start sharing again here. All right, so let's start with style transfer. So I'm sure, as I've mentioned, style transfer is like probably one of the more well-known things you can do with machine learning art. And as a reminder, what it does, it applies the texture from one image to the content of another image. And here's a couple links. So to the GitHub repo that this is based on, there are, again, papers you can read if you want to understand sort of the science behind this. And then lastly, this Collab notebook is what I recommend actually playing around in. And again, you won't need to use Paperspace for style transfer. So it saves you a little bit of money and time for training other things. This is a video that shows you how to do style transfer. I think this will just show you how to do it on Paperspace. So it probably is a good idea if I walk you through the Collab version today. So I think I've shown this in a couple different classes now, but these are essentially the layers of a machine learning network. In this case, is a classifier, but actually what you really like, this could work for an image generator as well, but essentially, again, there are layers here. Each of these layers contains either edges or textures or features. And as you get further down, you get closer and closer to like really exact like dog features. Whereas the top layers, you get like lines and shapes and those sort of things. So we actually use these layers to do style transfer. And the way this works is you'll see here. There are layers that can look at just style, right? So this could be texture layers. So maybe these are just sort of that mid layer of network. And then there are other layers that give you like the full shape and sort of shapes and outlines and features of images. That might be a little bit of a deeper layer. So then using some fairly complicated math, but it is just math, you can basically add these images together. Basically, again, taking those features and taking those layers, and you can add them together to produce new images. So that's essentially what you're seeing here. Is you're seeing here's what the style looks like. You're seeing here's what the image looks like using those layers. And then when you combine them, you get one image. So again, in this case, like the inputs for this are like, I need a content image, so you'll pull the content and shapes out of. and then you need a style image to be able to pull the style and textures out of. And you can combine those together to get one image. Really quickly, I'm just going to pull up the Collab Notebook. I probably will not go through it right now, and maybe I'll save some time for the end of class. But if you have ever looked at Colab, you'll see that it's going to take a little bit to load. But essentially, like, you can run the same types of commands that you run inside of Paperspace directly in Colab in a notebook, what's called a notebook. Let's see if this loads. I might come back to this. But this is sort of the command that you're going to look at running inside of Colab. So again, you're just running a Python script and you're calling this neural style py command. Then you're passing it a content image and a style image. And we'll talk a little bit more about these other things, about iterations and some other things a little bit later. But basically, this is a pretty simple command. Max size determines the size of the image. So whereas with StyleGAN, you have to be very specific about what you're training the images on in terms of scale and size. With neural style or with a style transfer, it's a little bit more flexible. You can actually just tell it the size you want to generate the image of. Now you will hit a certain point where it maxes out. In my experience on something like Colab or something like Paperspace, you can do about 1400 pixels for the tallest side. Sometimes you can get to 1500 or 1600, but it's pretty rare. And square images might have to be like around 1200 or so. That just maxes out the GPU. So you have to be a little bit careful about what your max size is. It'll just throw an error if you set it too big of a size, but you could sort of play with how big you can actually make something. See if it's loaded. It did not. Let me try this from here. Let's go to Colab. Let me switch my account here real quick. All right, so sometimes when you load it up on GitHub, it throws an error. I can also send out links for this directly, which is a direct link to the Collab Notebook. One thing you'll have to know is that when you get this from me, it'll likely, you won't be able to edit it. So what you have to do is you have to go to File, make a copy, save a copy in Drive. You do need a Google account, I should mention that. For Collab, you do need a Google account. So if you don't have one, you have to set one up. You can make it as anonymous as you want, that way Google can't track you, those sort of things, but you will have this. So I'm not, again, I'll probably talk about this notebook a little bit later at the end of class, but essentially all this is there's text here, and then you can read the text, and then you'll see these gray boxes. These look like code. You can actually just run the code in this box. So you can actually press this play button, or the other thing is you can hit shift return inside of one of these boxes, and that will run that command. So really quickly, I'm just gonna run this. You'll see it starts to spin, it's running. This is going to basically just return something. So as you go through this, you'll also see there's a ton of text below these gray boxes. That's essentially the output that you see from your from the server that you're sending it to. That is sometimes when you come into this and you see someone else's code, you'll be like, did I run this? And it's usually the case that this is just the last. It like saves it from the last time that it was run. So you can just ignore a lot of this until you run your own command. So as you basically run through this, the other thing that's important to know is that when you run a cell, if you run a different cell, it sort of is sequencing in an order, just like you're typing in those commands in a Paperspace. So if you are changing directories, you want to make sure that you're always in the right directory as you move around. That can be one of the few confusing things about Colab. But as you go through, you'll also see, like, I've hopefully done a good job of sort of outlining a bunch of different commands and arguments that you can use within this library. And you can run each of these commands. So you can read a little bit about what you're doing. You can run an example command and sort of see what happens. And then you could also, like, once you sort of have like play with this a little bit, you could upload your own images, and then you could start to play with it and like edit a line of code here. So it could be my image.jpg, and it could be my texture.jpg, and then you can run it. So this is basically like, it's almost like an interactive way to use Paperspace. This is not Paperspace, these are some Google servers. Another important thing to know is that with Colab, when you run out of time, all of your files are deleted. So you want to make sure you're saving stuff as you go along. And when I run through the full demo of this, we'll talk about that. But basically, this is some of the things you can do within style transfer. So you'll see, see if I have some examples here. So you can play with the scale of things, the iterations, which we'll talk about in a minute. Basically, this notebook should list every single thing that's possible within neural style transfer, at least the stuff that I use pretty frequently. I'm going to jump back to my slides here. Talked a little bit about just assigning a content image and a style image, and we talked about size. Let's talk a little bit about iterations. So iterations are kind of similar to how long a style GAN model trains for. Iterations is sort of the style transfer version of that. It means how long did this thing bake for or cook for. And I've got here just this is a really simple style transfer image. And then I'll quickly click through to let you see how each iteration changes. So this is 100, this is 200, 300, 400, 500, 600, 700, 800. I think I might stop at 800. Let's see. Yep, looks like I stopped at 800. I'll go backwards now. So 800, 700, 600, 500, 400, 300, 200, 100. Now, you're probably thinking to yourself, how long should I bake this for? And the answer is basically like, which of these images did you like the most? Because each of these only takes 5 minutes to process, you should just play with this. You should generate a bunch of different iterations and see what you like most. As you'll see, like overall, I wouldn't say like the images are that different. They're very subtly different in terms of color. There's maybe some slightly different textures that are being brought up here. I personally tend to find that I use like around 500 or 600, and it's generally like the right thing for me, but to each their own. It's sort of up to you what you want to produce. So as iterations. The next thing is a thing called style scale. And the way that's best to describe this is that you basically have two images and they're sitting over, like imagine them sitting over top of each other. If your one image is really small, it's going to try to apply the textures from that smaller image to the bigger image at that scale. So this is basically saying like make the two images the exact same scale, and then take the textures from those and apply it to the image of the other one. This is again a value that I recommend playing with. If your two images are about the same size when you upload them, you'll generally get like a 1-to-1 scale. But it's also worth playing with actually making that scale smaller or larger. So this is scale 1.0. This is scale 0.75. So you'll see like the details get a little bit smaller, right? So if you look inside of these textures here, everything gets a little smaller, and then it gets a little smaller still at 0.5. And then at 2.5, it actually picks up the textures of the entire image. And it turns the image itself into a texture. So again, this might be a cool look. This might not be a cool look. It's sort of up to you. But I definitely recommend playing with these numbers a little bit. And I wouldn't say like 1.0 to 0.9 is going to be very subtle. So like, don't play with it in that way. It's just like, I mean, maybe you could if you really want to dial it in, but I would try like 0.25 at a time just to sort of see how things are different. And then if you're like, I really like this one, but I also like this one, you might want to do like 0.6 or 0.65 just to sort of see how it changes.
And texture relates to the scale relates to the texture image?
Yes, yep, yeah. Because it's literally style scale. So it takes from the style image and it actually, what it literally does is it scales that image and then it uses the textures from the same thing. Because basically the way this model works is it takes two images of the same size and compares them that way. So in this way, what we're actually doing is scaling that image down. So if you do style scale over 1, you might actually get a blurry image, which is why I don't usually do it. So that's one thing to be aware of, is if you decide to go bigger on the scale, it might get blurry. You can also do some really interesting things here, which are to actually ignore the content image entirely. And then what you get is actually just purely like an abstracted version of the texture that the model sees. So this is using that style scale 0.25 of the previous image. And all you're doing is you're assigning the content weight of 0. So the thing about weights is like, how much of this should I be using? And we're basically saying like, don't use any of the content. So again, it's math where it adds those two together. So you've ever done like weighted averages of things? It's like basically saying like, don't actually add any of the content weights to the output image. And then you also have to pass in this image type of random, and that just randomizes the textures. So you get, if you actually run this over and over and over again, I think there's a seed value you can pass in and you would get different textures every time. Why might you do this? I don't know, it might just be that you want some interesting abstract shapes. This is again, there's different values and things to play with within these style transfer libraries that I think are sort of underused or underutilized, then I think there's lots of different things you might train this for. Like you could train this and then turn this into a texture for like a 3D map or something, or some sort of 3D, you know, UV mapping to something. So I think there's some interesting things you could do here. The other thing that makes the version that I am giving you better than many of the other versions that are out there in like apps or whatever, is you can also add, you can use two images together. So in this case, you'll see there are two images here, and I'm using both of their styles. And I'm, again, assigning a weight where I'm saying, use half the textures from this image and half the textures from this image. And when you combine those together, you get something that has a little bit more, you'll see it's got sort of these like weird warpy things that come from this image, but it still has some of the textures and some of the colors that come from this image. So this is where you get really, really interesting, where it's not just like taking a Kandinsky or taking, you know, a famous painting and like combining that like with an image, but you're actually beginning to make new images with different textures. And this is just a really interesting process that I think, again, like I would say like people kind of skipped on playing with this a little bit more. And I think there's some really interesting things you can do. You can also change these weights a little bit. So this is 0.5 and 0.5. This is 0.25 and 0.75. And you'll see it picks up a little bit more from this image. So these are in order. So like this is the Davey image, this is the Rodina image. I don't know where I named this from. I think this is Davey Evans, if you're familiar with his work. So it picks up some of the textures from that work. And so this one weights a little bit heavier toward this side. You can see the reds are coming out a little bit more, the blues are coming out a little bit more. There's a little less of sort of these curvy shapes. And here's the reverse. So you'll see there's more black in this. There's a little bit more of the texture from these images in the petals. And I think this might be the last thing I have here, but the other thing that's really cool about this is that you can actually take the textures and then bring the color from the original image back in. So in these cases, you're seeing it's picking up a lot of the color from these, and you don't have to just use the color from these images. You know, one thing you could do is you could take these images into Photoshop and alter the color there, and then re-upload them and use those as styles. Or you could also just like say, I want the colors from the original image. And this produces a pretty interesting sort of look where it's like, still has some reds and things in here. And I've never actually really mapped these two, but I bet if I mapped them over top of each other, you would actually see the color from the one image kind of shows up on top of the other. So pretty interesting. There's lots of little, there's so many little features of this library that I think could be played with for endlessly, like you could play endlessly with these things. And because it's on Colab, it's free, so that's even nicer. So yeah. And then the last thing you can do is you can do this with video as well. The thing I'll say with video is you can't do video on Colab. And part of that's just because I think I mentioned this earlier, but video just takes forever to process. So unless you're doing like a 20-frame video or like a very short video, you probably can't do this process on Colab. This demo is a video for how to do this on Paperspace. So if you do, or if you are interested in doing style transfer video, you can follow these instructions and look at them on Paperspace and be able to follow those instructions and be able to make a video. So the process for this is that you upload the video, you break them all up into frames. I do recommend that you actually use like the single image thing first to really dial in the arguments and the parameters you want for this. So you can actually take one of these frames that you've converted out of this video and just like play with it for a while. In part because, again, because video takes so long, you don't want to be like testing stuff and then find out like, oh, I didn't like this and it took me a week to actually produce this. So you might want to just play with an individual frame first, get that one frame locked in, and then start applying that to the video. You also have to do this thing called making optical flow. The optical flow basically is another machine learning model that learns motion, and it basically applies masking and other things to your individual frames so that it learns not to, basically like, because there's a lot of noise when you generate images using style transfer, this basically reduces a lot of the noise and it makes your images less flickery. So this is the process that the video sort of explains how to work it. Once you have all of that, then you can start actually training the video. So I'd say like, this is a pretty time consuming process. Like definitely don't expect to do it in an hour. It will take you a little bit of time. You can then just run the exact same neural style command, but then you have to pass in video. Let's go to path to the video. This style frame is all like, this is all the same, max size is all the same. You have to set a start frame and an end frame, and then a number of iterations. So this is all pretty similar. There's a couple additional parameters you have to pass in to do video, but it's doable. It like literally takes a little bit of time, like just to do it. Okay, so that's sort of it for style transfer. Let me see what time I have here. Cool, so it's 7:46. Actually, let me just jump into Colab and show you a little bit of how it works. Because I think this will be helpful to just sort of see using the examples that are there. Any questions before I jump into Colab? Cool, okay. So a couple of things about Colab. So you'll get a link to this notebook. Like I said, the first thing you'll probably need to do is like, you won't be able to actually edit it because it'll be my copy. So you want to come into File and you'll go Save a Copy in Drive. This is going to create a copy of your notebook. This is a pretty large notebook. This is probably one of the larger notebooks I've ever made, because there's so many different things you can do within this notebook. So I want to make sure that it's clear to people. I wonder if this is also my internet. Let's see. There we go. Okay. It's going to create a copy of your file. Going to load it. Here we go. Okay, so the first thing you're going to have to do is you're going to want to come over here and you're going to want to click on Runtime. And you're going to want to do Change Runtime Type. Very likely yours will look like this. It will say Python 3 and it'll say Hardware Accelerator None. So you want to turn on GPU. We know why we need a GPU, but this is a way to turn on the GPU in Colab. For many of you, this will be off, so make sure you turn it on. When you hit Save, you'll now be basically like running on the GPU. This is going to connect. It's initializing, and now you'll see here that you have a machine assigned to you, and you'll see that it has, wow, interesting. It's using just a little bit of RAM, it's using a little bit of disk, but you can sort of see what's available to you. If this green checkbox is on, that means you're basically ready to go. So usually what I would recommend doing is actually reading through these step by step, and then running each command as you read through it. So in this case, this just gets set up. So we'll just have to run this. So again, I'm going to hit Shift Return. In many cases, I'll call out if you need to actually edit anything in the Collab Notebook, but in most cases, you'll just come in and you'll just hit Run. So this is just setting us, making sure we're using the right frameworks for all the libraries, and now it's installed the Neural Style TF library. So we're, again, just going to click anywhere inside this cell and hit Shift Return. And this is going to download some stuff and it's going to start working. On the left here, you'll see there's a table of contents. This just basically outlines all of the different text pieces you'll see in this. So you could actually click around and jump to things if you know you need to jump to a certain area. These are snippets. I pretty much never use these. You don't need to worry about them, especially since you're not going to be writing a lot of code. And the last thing you want is the files. So this is where you can upload new images. So actually, let me come in here and see if I can grab an image really quickly from my Finder.
Is Colab kind of like interactive terminal or something like that?
Yeah, it is. It's essentially like, so there's actually a thing called Python notebooks, and that sort of is like what you might hear people refer to as Jupyter notebooks. Basically, like, because Python is big for the data science crew, like data scientists like sort of like being able to document their code in like these sort of experiences and then being able to run code. So basically this is like an option that they have available for that. I'm just gonna grab this image. So basically like now that I've run this code, you'll see there's a new folder here called Neural Style TF. I'm gonna open this and you'll see inside here you've got image inputs, style inputs, and video inputs. So I'm gonna grab this image and I'm gonna grab and put it inside of the image input here. The first time you upload a file, you will be reminded that files get deleted whenever your machine turns off. So make sure that as you're running through this, you're saving stuff. So I'm going to upload that. At the bottom here, you'll see that this is being uploaded. It looks like it might have just finished. So now I want to find a texture image next. So let's find a style image. So I'm going to come over here. Let me see if I have any good style images. Problem with doing this live is you get to see how messy my desktop is. Let's try one of these. you guys understand Brackage? These are some stills from his videos. So I'm gonna put this in here. You'll see it uploads. Cool. So now all of that is in there. So now uploaded things. I've got this installed, and now I want to just start reading through like sort of what I need to do. I might have some comments in here which is like, cool, let's just make sure we're in the right folder. This is the way to check to see what folder you're in. These are essentially the same commands you might run in your terminal window when you're in Paperspace. Usually the difference is that in terminal, you don't want this exclamation point, but when you're in Colab, you need that to tell it that it's a command to run. So when I run this, you'll see that it's just going to tell me this is with my folder location. And you know that because that's this root folder is called content, and you'll see there's a folder here called neural style. Okay, so a basic style transfer. Basic style transfer is really simple. You just literally run this command, and you've got a content image, which is what goes after this, and you've got a style image, which goes after this command. And these are already set up to read from these folders. So make sure you upload your content image into image input and your style image into your styles folder. So if you come over here and we just, I think sample.png was the one I wanted here. So I can just type in sample.png. And then for this one, I wanted what, 10176.png. And if I run this,
Derek, and here's where you can combine also two images.
Yeah, so I have an example of that. If you go back over to here and look at the table of contents and see options, you'll see multiple style images. So we click here, this is how you do multiple styles. So basically, I'm reading this from top to bottom, which is just like, how do I do the most basic thing down to the most complex thing? So I'll probably stop like somewhere around here.
Got it.
And then you guys are welcome to sort of keep reading and keep experimenting with things from here. So this is now running, it's still running. These things take a little while to sort of process. So again, this takes maybe 5 minutes or so to run. Also, you might see some error messages in various places. Unless it literally says like in bright red that there was an error, it just means that there's some sort of like dependency thing that is doesn't match up but isn't throwing a full error. So as long as this is running, that means this cell is processing. So again, this might take a little while, and I'm actually going to let it run for a little bit and just come back to it and see how it's going. While this is running, let's look at some of the options here. So inside of style transfer options, you'll see there is output size. So we can change the size of these images. One thing to note is that the larger the image, the longer it takes to process. That probably makes sense, but just so you know, in my case, I think this defaults to 512, but this is also running kind of slow, so maybe it actually is higher than that. So the larger you make the images, the slower it will run, and it will also sometimes, if you make this too large, it'll die. So if I were to make this 3,000 pixels, I guarantee you it would throw an error. And it might take a little while before it throws that error. So just be aware that you do have to like play with the size to see if see how big you can make it, especially on something like Colab. Colab's a little bit, it has a little bit of a smaller GPU than our Paperspace machines do. So you might not be able to produce as high res of an image using Colab compared to Paperspace. See if this guy stopped up here.
Is there any advantage of using black and white images, grayscale images?
No, I think it's just, these are sample images that come with this library. And they just have a black and white lion photo, and you'll see it actually becomes colorized when you do it. It really doesn't matter at all with color or black and white photos, because really all it's looking for is the texture. And probably actually has to convert this black and white image to RGB anyway, so it doesn't really matter. But here's an example of where these are using the two sample images that you have that you can then see what it produces using those combined. Let's see what's going on here. I feel like this might be way too slow. So I'm just going to stop this. So the way to stop it is just hit the stop button on this. And I'm going to change, I'm just going to make max size pretty small. Say 256. So this is going to make a very small image. But for this demo purpose, it's going to be a little bit easier to do it this way. So see, it's getting warnings, and those warnings are fine. You can ignore those. Okay, I'm going to keep going while this runs. The demo gods are clearly not pleased with me. So you've got some options here of output size. You've got options and iterations. So again, this is how long does it bake for? So in this case, I've set it to 100. That's going to be really like, this is, I think, is the earliest you can set the iterations for. I usually set the iterations about 100 a piece. In this case, it's just like 100, 200, 300. Again, if you do 250 to 200, it's going to look pretty subtly different. If you really want to like fine tune that, you can, but for the most part, it's just going to be fine as is. This is two different options of rendering different images. So here you'll see an example. This is 100, 500, 800. So 100, 500, and 800. I would say with this particular texture, you won't see a lot of differentiation, right? You'll see a little bit here in the whiskers. You get a little more detail, and you get a little bit brighter colors from these. Again, I find max iterations is something I need to tweak on a per image basis, so just play with it a little bit. Other things you can do, you can change the name of your folder. So one thing that's really important here is that like, if you just run that basic command over and over again, it's going to keep replacing your image. So this allows you to change the image names. So if you just change your image output directory and you give it a name, that will change that'll basically create a folder within this that has a certain name on it. And that just helps you keep track of stuff. And I would also recommend, I try to name my files with like, what's the content image, what's the style image, what's the size, what's the iteration. That way, if I like that and I like come back to it like a couple days later, after saving these to my desktop, and I'm like, oh, I really like that image, but how did I make that image? You want to make sure that you like kind of tell yourself some cues. Otherwise, you'll just have an image and you'll be like, I don't remember how I made this, and you'll have to go back to find it. Let's check on this one up here. Okay, single image elapsed. So if you see single image elapsed time, that means that your image generated. So what's nice here is it also tells you how long it took. This took literally a minute to produce. And I think that's because I cranked the size down. It was pretty fast for a 256 image. So if I go back here and I go to back to my folders and I look at image output and I open this, you'll see there's 1,000. Oh, that's actually what it was. It was the number of iterations that takes longer. So number of iterations you use, it takes longer as well as size. So it's probably like a decent size and it had a lot of iterations. But if I open this, the problem with Colab is there's no way to like just open this image and just look at it. One of the things you can do is here is there is like, you can run this command and this will export out those images. You just have to make sure that the folder names all match up. So if I run this, it's going to display the images here. This is pretty weird. I don't know what this thing is. It clearly didn't work as well as I would have expected. I guess what happened is it thinks these shapes are the outlines, and I don't know. It's pretty strange, but interesting. So this spits them all out. This is not generally how I work. I would generally like actually just take this image and I would just click on it and you can go download, and then it just downloads it to your desktop, and then you can just look at it that way. So if I go here, it opens in my Finder, and I can look at that. Now again, this is 1,000 iterations. It's a pretty small image. I bet if I were to do, let's see if this runs a little bit better. So if I come back up here, so now again, remember each of the times that you run this, you're running the same command, and you're running them in order that you actually are entering shift return. That's really important. So I'm gonna make the max size larger. So I'm gonna make it a bigger image, and then I'm gonna do max iterations, and let's just say 300 to make this process. But let's see how changing this changes the image. This is going to run again.
There's any way that we can get more than one image, like, I don't know, probably 10 images at a time? Or
no, so the way that these models work is
image?
They just produce one single image. And if you run this multiple times, you might get slightly different images, but they'll mostly be the same. So this is sort of what we call a deterministic process, in that it does produce just one image at a time. And that can be frustrating, or it can be annoying, or, you know, for some people, this is sort of the process they want, so they feel like they have a little bit more control. But yes, you do only get one image at a time.
And as far as rotation goes, I mean, if you want to, like, if you rotate the image and put it back in, that might give you different results, or like...
It might, yeah. It just sort of depends on how the textures are oriented. So like, if you were to use flames, which always point up, and then you were to give it a flame that points to the right, it's probably going to learn that direction, but it won't always learn it in the way you expect it to. So there are some You could try rotating it and just see how different your images are. But in many cases, it's going to be like fairly similar. There you go. So that one just finished. That one took 10 seconds longer. So for double the image size, but like a third of the iterations, it ended up being just a little bit longer. And if I come over here, if you don't see this that file here immediately, come up here and just click refresh. And sometimes the folder just needs to be refreshed so you can read it. So here's this image. I'm just going to download this and look at this and see how different it is. Okay, cool. So that picked up more of it actually learned that the flower image should have more of the color on it, but it still kind of made stuff black. So like, I might try experimenting with different style images just to sort of see what it learns. The other option that I might go to, so what I'll do is I'm just going to copy this command, and I'm just actually, you can always make new cells. So the way to make a new cell is to run to the bottom of this, and you'll see if you hover over this, you'll get either a text cell or a code cell. Let's click code. Excuse me, I'm going to paste this in again. And this time I'm going to change the style scale. And if I want to figure out how to do that, I'll go over here and I'll look at these options and I'll see style scale. And it'll say, okay, the way to change this is the style scale argument. So let me come in here and let me just grab style scale. I'm going to play with like 0.5 and just sort of see what that looks like. I'm okay with overwriting that other file, so I won't change the image output directory just yet. Let's come back up to a basic style transfer. I believe it's this frame. And I'm just going to paste this onto the end. And let's run this again and just sort of see what happens. So one thing to remember is that like now I have two different cells here. So if I forget which one I'm running and I like run the wrong one, I will get a different image than I expect. So one of the things that can be tricky with Colab is it's very easy to just start making many, many cells of new things, and then you have no idea where you are. So usually what I do is I like make it very messy for a little while, and then I clean it up. And I will probably clean this file up at some point, although this is just a demo file, but my original, which is here, I think is fairly clean. Like you shouldn't run into anything that's super weird, although sometimes it does happen. Like usually I'll stick stuff at the very bottom of the page where I might have some, you'll see there's an empty cell here, and that might be because I need to run some commands to like clean some stuff up. You don't necessarily need to worry about that. Let's take a look at this, see where we are. Just gonna keep going. Should have a new image by 8:05. Any other questions while we wait? Cool, this just finished. Let's go back to our files over here. Let's refresh. It probably just overwrote this folder, so I'm just going to come over here and click download again. It's just going to make a duplicate in here. Open this. And what changed? Well, not too much. You'll see that the blobs are a little bit smaller, but it's not. I personally think it's better, but it's not that much. So some things you'll see here is like sometimes certain images just don't work very well. I would probably try to find a different image to play with as my style. It might also just be that this thing is too small. I do find that if you scale images up, you get a little bit more of that texture and a little bit more interesting detail. But for this demo, that's going to take quite a long time. So I don't want to sit here and wait on things. But actually, let's do this. Let me just run this command. I will run it at a larger size. We'll look at some next stream prediction, then we'll come back and check on this once it's finished running. I'm gonna set this to 500, leave that at that, and let's just see. Okay, so let's go back to our slides. Let's look at next stream prediction. Okay, so as I've shown you before, next stream prediction is a very weird model that takes motion and just sort of like distorts the hell out of it. Here's an example of Jonathan Fly's roller coaster ride. Clearly not an accurate prediction of what each frame should look like, but it is still pretty interesting. So as a reminder, next stream prediction is a really special version of Pix2Pix. and it basically just pairs images, each frame with its previous pair. I have a tutorial for this. I have a demo for this. Actually, this is a tutorial that someone who wrote actually some of the code for this library, they put together a tutorial on how to use it. And then I have a demo of how to use it in a video that you can watch whenever you're ready to get started on this. Training data for this is that you break a video into individual frames. And then what you do is when you actually want to test it, you give it one single frame, and then you can request as many video frames out of it as you want. This is the demo video. Feel free to watch it at your leisure. The steps for this are pretty straightforward. So you're going to upload a video to the Pix2Pix HD folder. This is already installed in your Paperspace library. So you'll find a folder called Pix2Pix HD. You will upload a video in there. And I recommend for this that the video be exactly these dimensions. Anything outside of this dimension is going to get kind of weird. So I just recommend like bring it into After Effects, crop it, or like use whatever video tools you want, and just like make sure the video is on this size. If you have something that's smaller than this size, what I've gotten away with is I've just like matted it on like a black background or a white background, and it's been fine. So that's an option as well. But I would just generally recommend using this size and just work a little bit easier. You'll need to separate the frames. This is the command you're going to run when you're inside of the Pix2Pix folder. You'll run this command and it'll break them up into different sizes, or actually, sorry, just different frames. And then to train the model, you're just going to actually, whatever you input here as your data set name, you want to use that again here. And you're just going to point it at the data set. You're going to give the project a name, and then you're going to run this training process. And the training process can take a while. It depends on how long your video is. So if your video is very short, say 10 or 15 seconds, the training process can be pretty fast. But I would also say what it's learning is going to be like maybe more messy. It just sort of depends on the motion for the video. And I'll talk a little bit about that later. But essentially, like this is the process for doing training. And then when you're done with training, which can be any point, like you can stop the training and just generate a video, which I will generally do. What I'll generally do is I'll run it for maybe a couple hours, stop it, generate a video, see what I get, and then you can continue training it from any point in, and this will generate a video for you to look at. There's a bunch of options here when you're generating a video. This is how many total number of frames you want. So this does work at 24 frames per second. So this is less than 10 seconds. You could make a longer video, a shorter video. It doesn't really matter. You can play with that and sort of see what you want. Epoch is like iterations. As you train, it generates epochs. So the later the number is, the longer it's trained for. And you might find that you get better results earlier or better results at the end. It's just, it's different for everyone. You can also then pass in a frame that you want it to test from. So say like in the case of that roller coaster video, you actually just wanted to give it a picture of your face and see what it did to your face. You could do that. In my experience, starting from a different video altogether lasts for a little bit, and then it basically converts back to what the original video was. It just like the colors all morph back into where it was. But you're welcome to try it and see what it is. You can also pick it from a different frame of that video and see what happens at that frame. I'm gonna stop there for a second. I just want to check on that style transfer image and see what happened there. Sorry, I'm bouncing around a little bit today, which is just how I'm feeling, I think. But we can look at this and sort of see what happened. I want to do that before this machine shuts off and I lose this image. So let me do this, download. And I can open this. And that's kind of already better, right? Like lower res, like you kind of miss the textures, but as it gets bigger, it's picking up a little bit more of those textures, getting some leaves in there. Maybe not my favorite image, but it does work.
I'm sorry if you already said this before, but what's the max runtime before it shuts down and closes you out of your session?
So Colab has 8 to 12 hours. They don't really say exactly how long it is. But the other thing is if you're not running a process, so this was running, if you're not running a process, it'll kick you off after 10 or 15 minutes if you're not running anything. So basically if you're idling, or if you're even writing code in here, it might stop you. And the only thing you'll lose when it stops is your files in your folders. You won't lose the code you're writing, but you will lose some of the images and files that you have. So it's important. Sorry, go ahead.
The files that existed in the, like, this is called a notebook, or?
Yeah. Mm-hmm.
So the files that existed in the notebook that you edit will save changes that you make, but then the new files generated disappear?
Well, okay, so let me just actually force quit this runtime and we can look and see what happens. So basically, like, this folder existed because up here, I said to install this folder.
Yeah.
So if I restart this runtime from scratch, which is factory reset runtime, I will lose that folder. It's going to need to reconnect.
Gotcha.
And then what you would have to do is when you reconnect, you'll actually want to start from the beginning again and run this command and then run this command. And then you're back to sort of where you want to be to start actually making the commands or training the files, because this just installs the library for it. So all you really need to do is go back to this step. But all this comes in when you import that library. And then the files you upload, you lose. So you have to re-upload those files.
Okay.
So that's the downside of Colab, is you have a short window of time to work. But in this case, if you're constantly running different uploads, it'll generally keep open for about 8 hours.
Okay.
And I'll also say, like, this is a part of like Google's whole network of other things. And I've actually noticed this week, because a lot of people are running notebooks on data sets about the coronavirus, that I actually think I'm getting kicked off of Colab pretty quickly right now, because I think there are a lot of data scientists who are crunching numbers around virus and projections. So like, I have been getting kicked off very quickly when I'm not running a process. So it is something to be aware of, that for probably the next couple weeks, like, it's going to be a little tenuous to sort of like run these things. Now, that's not to don't be scared about doing it. It's just to say, like, make sure you're running stuff pretty frequently, because after 10 or 15 minutes, you might get kicked off of it. So they can use that server for someone else.
Okay.
Hey, Derek, I also read that they charge like $9 or $10 per month if you want to have like a pro account. Is
Yeah,
that
so
correct?
Colab just released a pro account. The pro account supposedly gives you access to better machines, and it gives you a slightly longer running time. And I say slightly because they really don't tell you how long your actual runtime is. But so if the basic account is 8 to 10 hours, I've heard that the pro account is 12 to 14 hours. And that's like a continuous process, right? So like, if you think about like StyleGAN training, it would kick you off after 8 hours of training a StyleGAN model. And this time it'll kick you off after 12 or 14 hours. Now you could save that model, reload it, restart it, and like you could kind of batch it, but it's like gonna be really annoying. Colab Pro, I just signed up for it actually to try it out. I'm not as sold on it being that much better. The truth is, during really high traffic times, it might be better because they give you preference for getting a better machine or getting faster machines. So it might be better, but in general, like, I would say, like, most of the time I find that it's about the same machine, and this is free. So it's up to you. It just depends on how much you would use this for, right? If you're going to use it every day, you might want the pro.
Okay. Even if you pay $10 per month, you don't have unlimited time. You
do not have unlimited
always
time.
have, okay.
Yep. Yeah. So it is, you cannot use it like you can use Paperspace, where you can let it run for 5 days in a row. That is on purpose, but that is definitely like something to be aware of with Colab, is that the $10 just gets you a couple more hours of time, but it'll still cut off your system and then restart it later. So yeah. Okay. So back to next screen prediction. Sorry, I realize I'm bouncing around a lot today. Next screen prediction versus StyleGAN. So I think we talked about this a little bit last week, or maybe the week before, which is like, how does StyleGAN interpret video and how does next screen prediction interpret video? So StyleGAN, again, like, all these things get broken up into individual frames, and it tries to memorize certain parts of the frames. So StyleGAN understands the images and a generalization of the data it's given, right? So it understands all of the structures that you're giving it, but it doesn't understand time. It has no concept of like, this frame goes before this frame goes before this frame. What it might end up doing is it might end up clustering features. So if you were to imagine giving it a video or a movie, like a full length, like 2-hour movie, it might cluster all of the like close-up shots of people talking to each other, and it might cluster all of the wide shots for like establishing shots. But that doesn't mean it understands time. It just means it understands these images look alike, and therefore they should be kind of close to each other. Something about that. It does not understand time. So I think I've shown this example multiple times. Like, this understands waves as a visual structure, but it does not understand waves in terms of time, right? It doesn't understand that they start at the top of the page and they like go to the bottom of the video. It just sort of like sticks in between this based on what it's seen. This is an example of StyleGAN looking at video. Whereas next frame prediction understands time because, again, it's looking at the various frames. But I would say it does not understand image structure to the same degree that StyleGAN does, right? And let's look at an example of this. So this is, again, I think I've shown this one before. These are the fish. So when this runs, right, it knows where the fish is from a texture perspective, but it immediately obliterates it because what it's really looking at is the basic motion, right? So this is like underwater motion. It's like kind of like moving back and forth a little bit and up and down. It's like floating essentially. So it does not know what a fish is supposed to look like, right? It doesn't know that fish should keep that structure and just move within that space. But what it does understand is it understands motion. So it's basically taking all of the like visual texture it sees and trying to apply motion to that. And that's why we get really interesting results, but it's also why it generally like often will look like it's not actually like representing images. So some other recommendations I would say using next frame prediction is that next frame prediction learns really basic motion. So like in the case of that, that roller coaster, that's great because it sort of understands like zooming and moving through space. I would say that next frame prediction is not good at very like jittery motion, like it just won't understand that type of thing. So in some cases better if your motion is slow or smooth. I would definitely recommend if you have like a video you want to use and that video has cuts in it, cuts are going to confuse a model like this, right? Because if you think about what it's actually training on, it's training on one image and then the next image. And if there's a cut, it's gonna be like, whoa, this is completely different than anything I've ever seen. What do I do with this? So in general, I recommend videos that don't have cuts in them. I would also say like, I have personally found shorter videos, like say 15 to 30 seconds or up to a minute are generally better than longer videos. And especially better than longer videos with cuts. I also think longer videos just take a lot longer to train. And if some of what you want to learn is like, just sort of see what it produces. Long videos, like 5 minutes long, are going to take forever to train. So you might want to just pick a shorter passage of that video and see how that works. And then if you want to try it on a larger sequence, you can after you've sort of learned some things. Another thing that's really important with next frame prediction is that every one of these iterations is very different. So what you saw with StyleGAN, for those of you that started training, you notice that each iteration is like a slight change from the previous one. With next frame prediction, that is not the case. With next frame prediction, almost every iteration is very different. And there's reasons for why that is that I won't get into now, but it's basically like, it just is kind of like madness in some ways, and it's trying to learn a lot of different things all at once. So therefore, each iteration will be a pretty big leap. So here's some examples of this. So this is a video that I trained on flower blooming. This is epoch 39, so keep a track on like what these numbers are. Basically, 39 and 40 will be the closest to each other. Just in terms of training time. That's sort of like fakes, where like the fakes that are closer to each other in numbers tend to be really similar. It's a similar idea here, but you get different results at each of these epochs. So epoch 39. Good there. Epoch 40. So this is the literal next epoch. So look at how different it is, right? This one's way more little pieces. It's got way more like these flashing like disco lights. It's just super different. And this is where it differs from StyleGAN, where I would say StyleGAN, you want to look at every 100 fakes or whatever, like to sort of see the differences. With next frame prediction, it's pretty much want to look at like every individual epoch because you're going to get really different stuff with each one of those.
Say that you wanted to take any one of these epochs and like kind of make it evolve to a final frame that kind of looks like alphabet soup, where like the forms spell out a specific letter, and you do the trouble where like, I mean, like I don't have like a specific example, but like that, yeah. I could imagine like basically going in and like using the same colors and the same background, like photoshopping something that's the exact end frame that I want. Like, how would you bridge that? Like,
so that's a really important thing to know, is that the way that next frame prediction generates images is it generates an image from a starting frame. So you give it one frame to start with. So in this case, what it actually ends up doing, this is a special, like, this is part of this model, is that it takes like the first like sort of like 60-ish frames of a video. So you'll see at the top here, it says original video. And when it turns off, that's essentially the first frame of the video that you're playing from. So like right there, it's like, yeah, it's right here-ish. Yeah, there. So like it's feeding this frame into the model. So you can't really get looping video through this because it only knows the starting frame. So it never knows the ending frame. So you could, however, like say, take the end frame from epoch 40 and use that as the starting for epoch 100. I don't know what that would actually look like. I've never really done that, but like it is, these are pretty difficult to sort of like control. They're
or is there a way
like
to
sort of out of your control.
methodology where like you do this and then you kind of like have a basis of like, okay, here's how I kind of like fake how the style looks, and then can you like switch to a different way of like combining that, like you do some of it in this like next frame prediction and then like there's a different thing that you do that makes the two things blend together in video? Like,
yeah, I mean, one thought I have is like you could take this video, do X number of frames to it, then bring it into a StyleGAN model, have StyleGAN actually learn all of the features of it, and then you could use the StyleGAN model to interpolate space in a looping function. I have thought about doing that, and I've never really just gotten down to doing it because it would just take a lot of time. But there probably are techniques like that that you could do with certain things. You know, there's also stuff like you could run things forward and backwards, and depending on how the sequence like actually looks, it would maybe not appear that's not really even looping. Hard to say without really trying it. But yeah, this is like one of the things with this particular model is it's a little hard to control, and it's a little hard to like actually control these particular moments. I think, Nyan, maybe you had asked previously, like, could you feed the same image back in and almost create looping that way? And like, you could try that and see if that works. Or like what you could actually do is, so let's say you take this frame, you bring it into Photoshop and mask out all the black, and then take your starting frame over again. And you could try to see if you could like overlap them and see if that would loop. I doubt it would work exactly the way you want it to, but it could be interesting to sort of see and try.
Cool.
And then lastly, I want to show epoch 145. So this is way, way further along in the training. And we'll sort of look at, we'll look at this one. And so this one almost ends up being kind of a merge of both of the previous epochs, not by my choice. It just happened that way, that this one happens to have both flashing and some really interesting just like structural things. The thing I would say about the further along you get in the epochs is generally like you will get frames as soon as they start. So right here, like you'll see like this got maybe 30 frames in, and it generally still keeps its structure pretty well. That's sort of how you can tell things are learning more, because it's able to predict like that very short sequence of time right after it switches over. It's able to predict that fairly well. But in this case, it's still like, no matter what, it's pretty much always going to devolve into sort of madness at the end. So just worth sort of like knowing that like, there are cases where I actually have had it train almost exactly the way it was trained on the test set. Whereas like generate the images exactly what I was training it on. And it's almost a disappointing moment because it's like, well, all it did was recreate the video that I expected it to. So you almost want to embrace sort of the craziness of these models.
Sorry, about what you were saying earlier, taking the black out. Do you mean with the final product you would take the black out, or like for the original video that you're feeding in?
Yeah, that's a great question. I'd probably take it out of the original video, right? And then you would overlap that video over top of it and see if you could like have it pick up from there again. This is probably a bad example because this sort of explodes all over the page. But if you have one where it's sort of contained, you might be able to just like almost like blend in the other image and see if it overlaps and see if it picks up again. I actually have no idea if any of this would work. I just like, this is me like speculating on ways I might try to make these things loop. I have no idea how. Honestly have no idea how to make this thing loop. But I think it'd be interesting to sort of see if we could figure out a way to, or like a way to fake it looping. I don't know.
Right.
Yeah.
Well, there's loop, and then there's like if you want the flowers to spell out like love or something, and you go in and you like, and I like carefully kind of like clone and whatever that it like sort of like looks plausibly like something that could have been generated, like how it, so I don't need to loop, but it's like having like very, very, very aggressive control over the final frame that's like contrived. Like, how would you do that? Like,
probably in After Effects. I would probably like end up doing a lot of masking and just like cutting all the, like basically like generate a bunch of videos of these pieces and then like cut out the pieces you want, mask it in. Like, this is where it's like, cool, you've generated some interesting materials, but now you really have to make the end piece using these materials. I think that'd be cool to see, but like, I have never done that because that sounds painfully arduous, but like, I'm sure you could do it.
I was hoping you would tell me, oh yeah, you just do like this other method. Like, no,
there's no other method, unfortunately. I can actually show you. So if you're actually interested in letters, I'm currently working on a model that is called Shape Matching GAN. I'm currently trying to build this so we can actually use it in class, but this actually learns textures and then shapes, and then you can create shapes from letters.
Oh, cool.
So this is like a cool thing. I might know how to do this by next week. No, fingers crossed. I've actually got it working pretty well. The problem is training takes a little while with this. It takes about 6 hours, which is like right at the limit of Colab. So you can almost do this training in Colab, but you have to keep a careful eye on this. But this is some stuff I'm working on. So again, maybe what you want to do is if we learn how to do this, you would take the textures from this image or this video, and then you would bring it in, and then you could try to apply these textures to, oh God, sorry, you're seeing my life here, which is just like, where did that thing go? This model. Yeah, so you could then apply it to this and see if that could work. This is where it gets really interesting, where like people have not necessarily changed a lot of these models together in ways that are interesting yet, in part because most of us don't even know about these models. So these are places where you could begin to be like sort of the leader of experimenting with these things.
This looks awesome.
You remember that video that we watched where it was like finding Mario within like the
projection? Yeah. Yep.
Is that a technique that could work here?
Possibly, but again, projection requires style GAN. There's no projection within next stream prediction. So a lot of what you'll find is like, you'll be like, I want this thing from this model to do this thing in this model. And it just doesn't work that way. Or it doesn't work that way yet. So you might be limited based on just what models you know are available to you and what you can work with. So yeah, my hope is that like, as I teach more of this class, I'll have more models available to everyone to be able to experiment with these sort of things. Okay, so that is sort of like looking at these different epochs.
Is there a next frame prediction in Runway?
So next stream prediction is not in Runway, in part because you need to train it. So with all these next stream prediction models, you really require some training time. Also because next stream prediction is a hack on pix to pix, there's really no actual model that says, here's how to do next stream prediction well. So this is not something you can do within Runway today. I've debated trying to bring in some of this into Runway, but like the thing is you can't do training on custom models yet in Runway, so it's still not possible.
Also, training in Runway is only on models that they existed, not on community models?
So training within Runway only exists for StyleGAN and a model called GPT. GPT is a text generator. So they only have training for those two models right now. I think I've heard from them that they want to open up training to do more different training models. But that would require someone like me to probably go in and actually build it. And that just hasn't happened yet. So you could, I mean, theoretically with a pretty short video, you could train something like this in Colab. And you might just have to do a couple sequences. So basically like the way that this would work with Colab is you would train it for the amount of hours you have available to you. You would then download that last checkpoint file. So like a pickle file in StyleGAN has a checkpoint file in next stream prediction. They're all the same thing. It's basically the model math. You would download that and then you would restart your Colab machine, upload that file, and then continue training from there. So you could do it. You just have to basically sit there and like every 8 hours switch this thing over, which I just generally don't have the patience for. But if you really want something cheap, you could do it through there.
They don't give you a warning before they shut down the machine, right?
Nope. Which is why, since 8 is like the floor, And usually as long as your machine is running, they won't kick you off of it until you hit that like high limit, that ceiling limit. So because 8 is sort of the lowest end of that limit, most people just set like a timer and like it goes off and they come back and they like quickly download their model and save it. You can also save your models to Google Drive. You can actually connect Google Drive and Colab together. So you actually have them saved, and then when it shuts off, the hope is that it's already been saved to Drive. There are issues with that about things being saved only halfway or other things, so like you have to kind of be careful. But you could do some work like this on Colab. I think Jonathan Fly, who was that roller coaster video, I think he might have trained that on Colab. You just have to have way more patience than I do. And it's like, you ever hear that thing about, I think Steve Jobs was talking about like iTunes versus Napster, and it's just like, well, people who have more time on their hands are willing to use Napster to like play with stuff, and people who don't, like, well, generally you just pay for iTunes. And it's the same thing with this. It's like, if you're willing to go through a lot of headaches, you can use Colab to do a lot of stuff, but you have to be willing to jump through some hoops and like be willing to like sort of suffer for it, but you do get it for free in the end. So just sort of up to you what you want to sort of take away from that. So that is everything. Let me check, see what time we have here. So we're at 8:30, we're about half an hour left. I'm interested if people have questions about this, if people have questions about StyleGAN. Do you want to talk more about what we could do next week? Like, what are you sort of interested in? Okay, so next week, yeah, go for it. So next week, like, we have the option of just like, I can work with every one of you one-on-one and just work on a model you want to make. We also have the option of, I can show you some other models. Like I can show you how to do shape matching GAN. I can show you how to do cycle GAN or pix to pix. It's sort of just up to you. It's like, what are you most interested in? Do you want to work on your project, or do you want to see more models that are available to you? That's sort of how I would explain it. It's like, it's sort of up to you what you're most interested in working on.
Yeah, I'd love to have you help me work on my project.
Cool, okay.
I would agree that just like watching people get help on their projects and having them share out is like really interesting to me, because I'm like seeing at the same level you're at, but I'm also super curious about the shape matching GAN. Like that's really cool. So
yeah, I mean, the other thing I can do is I can just record a video on how to do shape matching GAN and then just share it with like in the Slack channel, and then people can like pick it up from there.
Cool.
Because I also find that like my recorded demos are always much better than my live demos, because my live demos have issues with like, this didn't work, or we're just waiting on things. So in general, my like video demos are better. And then I think I sort of feel like you should get the time out of this class by working with me directly if you can. So maybe that would be my suggestion, is that for next week we'll sort of like work through things. And if you want to, if you're like, I don't really want to watch you help other people, I'm happy to just like say, like, just let me know over Slack, and I'll just be like, cool, why don't we just plan on having you at 8:30, and then you can come at 8:30, and then I'll work with you. But I know some of you others like do like to watch me work through other people's work. So if you want to do that, that's also an option. Just like message me on Slack or email me, and we can sort of work through those things.
In that case, could you also have, do you already have CycleGAN or Pix2Pix tutorials like available, or if not?
Yeah, so I have a CycleGAN one, and I can record a Pix2Pix one pretty easily.
Awesome.
Because you're going to do Pix2Pix, is that right?
Yeah.
Cool. Okay. Yeah, I can definitely record a video for that. And then also you and I can also talk either like at any point, like we can talk about going through it. So yeah.
Before next week. Also for Pix2Pix, how many images did you say that like you would need for the data set?
Probably say about 500.
500? Okay,
yeah.
Cool. Right.
We can always try working lower with less than that, but I just can never guarantee that it's going to work. I'd say 500 is like a safe number.
Okay. Well, the thing is, like, I wanted to do like veins on mushrooms, and like I was saying last time, and I had planned to go to like bookstores to like rummage through like all of these like photo or illustration books like this week, and then this shit happened, and so I'm like, oh, okay, what can I get that's like available online? And so I'm finding like coral reefs that are really cool as well. Mm-hmm. So I'm trying to, I'll like dig through those and like scrape like Instagram and Google Images and.
Cool. Yeah, and also let me know if you like, if I can help find some resources, I can also do some work for that too. Okay,
awesome.
I know if you want, if you want non-photographic things, there's a place called the Biodiversity Heritage Library that has all vintage illustrations. That's a lot of where my images come from. So I can send you a link to that. That will be illustrations. So like there are awesome books on mushroom illustrations and stuff in that.
Yes.
You just have to find that in that. It's a big library, but I could probably like link you to some resources there.
Okay, awesome.
Yeah.
Thank you.
Yep.
There was also that blog, Bibliodyssey.
Yeah, so Bibliodyssey is another good resource. He hasn't uploaded anything new in like a decade, but his site is still good.
Okay.
Sorry, someone was asking me another question. What was it?
Oh, I was just asking what the name was again. I just missed it.
Oh, cool. So let me pull it up. So it is called the biodiversitylibrary.org. You can go there. They have a Flickr page. I would definitely recommend actually digging through their Flickr page first, because their website is all their books, and not all their books have illustrations in them. So if you go through, they have 166,000 photos up here.
Wow.
So you might actually also want to do, I think you can search by just within this. So let's look here, mushrooms. How do I do this? Let's try user. Actually, let's do this. So let's go in here. And then if you click on, I think if you just click on one of these images, but you'll see there's like a ton of images, like birds. You'll see all these birds that I've used before.
Oh, there is a search button at the top-ish, like on the right.
Yes,
like
there we go. Thank you. Cool. Okay, so Biodiversity Heritage Library. So like look at mushrooms, and you've got some mushrooms, all sorts of mushrooms. How many photos do we have here? 2,000 results. So maybe these will work, maybe these won't. You can dig through them and sort of see. This is a good resource. All of these are essentially out of copyright. I've yet to come across any that are still under copyright, but they sort of say like, hey, don't quote us if we tell you these are out of copyright. What's nice here is that if you go to these images, you click on one of these, it gives you a link to the page in their website, because some of these, so this one, for example, this one is about 2,000 pixels wide. If you go to the actual page in their website, sometimes you can get these larger than that. This will load for a little bit. And you can actually download the entire book. So if you go over here and you go to download book.
Oh, wow.
You can download, they're always JPEGs. They're a little crunchy in terms of compression, but they're usually pretty good. You can download the entire book. You will get all the images plus text, and you have to go through and weed them out, but it's honestly probably a little bit faster than trying to download them individually. And then if I come in here and I go, if you basically move this up to 100% and let it load. I think my internet is slow this week because everyone is online.
Let's hit just the corner of the page.
What's that?
No, never mind.
Okay. Once this is loaded, then you can do open image in new tab. I probably could have done that before even. And you can see, I wonder how big this is. Ooh. If I ever download this. So that's a much bigger image.
That's nice.
So like you can sometimes get higher res images on their web page than you can through Flickr. So Flickr is helpful, but it doesn't contain everything you want and doesn't always give you the highest resolution images. But it's nice to just sort of sort through it and be like, what's available to me? Because there's a ton of stuff in here. There's like so many images that are worth like just looking at. So it's definitely a good resource. Probably one of the best like online, like non-copyrighted resources for like botanical illustrations and things.
Sweet. Sounds good.
Okay, so who has other questions about their work that we can talk about?
I would like to retrain my model. As I told you yesterday, I would like to maybe select like a different set of files and then see what happened. Do you have any advice on that specifically? Or
so what I would actually, so what I would actually do for you is I would determine what your data set, what you want your data set to be. Like maybe you want just the close-up images, so they're all the crops, or maybe you want all the simple shapes, or like however you want to mix and match it. I would start with that. What I would then do is I would actually use the last pickle file of your current training and train off of that. The reason is that those images are already pretty close to each other, that it's going to train much faster. So you'll basically like get a new subset of those images, and it will train based on the data set you give it. So if you like narrow in the data set, it's still going to like optimize your old training, but it will just it'll learn faster because it's already got that pre-built sort of model that it can work off of. And I have a video, sorry, go ahead.
And do you think like 1 day will be enough, or maybe 12 hours of training will be enough? Like,
yeah, I don't
have too much credits left. So
yeah, I would guess that like 1 day is probably gonna be enough. I think I'll be fine. Because you're basically like shrinking your set, and it already knows most of your images, and all it's gonna do is shrink it down. So my guess is that it'll pretty quickly be able to like generate a new data set from that. Quicker than like training it from scratch, yeah.
Got it. It is okay to have like 1,000 images, or can I go down to 500?
I don't know, let's see. I mean, I would say try to keep it around 1,000. But if you want to go down, we could try it and just sort of see what happens. There's a chance it'll overfit and it'll just like not be able to do the interpolation. But I can't say for sure until I sort of like, until you try it basically.
So 1,000 will be safer.
Yeah.
Yeah, okay, thanks.
And I have a video, I don't know if I shared that video with you yet, but basically how to actually like pick up from another model. Basically you open one file from within the StyleGAN model, and you edit one line of code to point it at the new pickle file. I have a video for that, and I can share that with you. It's pretty straightforward, and if you have any issues, just let me know.
Okay, cool, I'll check it out.
Cool.
Do you have NetSpam prediction on Paperspace demo recorded?
Yeah, so I do. In the slide that I shared, there's a video in there that shows you how to do all of it. Yeah. Because you're gonna do the faces, right? Your face. You're gonna try it.
Yeah, I mean, I tried it already on Runway on that one free training. It looks kind of cool, but I think I need to like kind of like put more into it.
Yeah.
The more interesting parts were with the faces from the original set were morphing into my face.
Yeah. Thousands of Yadams, yeah.
Mm-hmm. Yeah, I'm sure it's on there on the channel.
Joshi, Lisa, what are you guys up to? What are you interested in working on?
I got the press kit from the Armory show of all the booths that were photographed. It probably is not okay for me to train like a machine learning generator on it, but like fuck it, I don't think they're gonna notice. But the images are really big, so I need to cut them down. And then I'm kind of not sure, like for my purposes, I don't think I really need a video, but I do want to just kind of get like a wide variety, because I'm not really sure if it's going to turn out like things more focused on the architecture, more focused on the art, but like the photography is like really consistent and the images are high res. So I mean, I kind of need like, I need to like sort through it, but maybe it would be helpful to maybe show you what I have to figure out even how to like crop it, if it should be like selective crops that are like closer in, like to do, I want the art to like vary and meld more than just like showing different like booths like turning into crazy Escher things.
Yeah, so what you might want to try to do then is try to match up where the booths like certain perspectives are, because it is pretty consistent. It'd be interesting to sort of think about like, could you get the architecture consistent so then the images are just changing? That just requires more setup when you're doing your data set, right? It's like overlaying everything to make sure they kind of match up, that sort of thing. So yeah, that's where it just becomes building your data set is the hardest part.
Yeah. I mean, like I have a lot of good high-res images. I was wondering if, so it's more about the compositional similarity having like close crops where the art is, but I guess maybe that implies a compositional choice, doesn't it?
Yeah, I mean, that's the thing is, it's like, you could try both almost and see what it learns that are different, right? Like if the art is overlapping perfectly, the art will meld, like the art will stay in a place, but it'll change how it looks inside, but then the architecture will change around it, right? So it's sort of like, that bird style GAN that I showed in the first week of class. Yeah. Like the bird was consistent, then everything around it changed, which was cool. You might get this where the art stays static, but the art internally the structure of the art changes, but around it changes the booth.
What, in your experience of like have your cake and eat it too, like say if I feed in like just like square crop, full frame, and then I also do like square crop where it's like really tight on the art, and then I also do square crop where like the art's just like one part of the corner, do I just get like a soupy stew and it just sucks? Or like, it's like, I'm wondering like what...
My hope is what you would get is you would get like clusters of each of those sets, right?
The one thing that's consistent with the white background is consistent, so it's just like the white cube does kind of like have this environmental like stability that like part of me is thinking about like edge detection, that it's like not white will be art, or like, and then the floors, it's like everything, it's like there are so many, like that's why I was like curious to play with this, is that like getting this like press kit that I'm like misusing like seemed fun. Like
yeah, I mean the truth is I also never know until I do it. Like even with my own artwork, I'm like, I think it's gonna look like this, right? And like I sort of thought Esteban's work would look like what it ended up being, but I didn't really know until we actually saw it, right? And that's sort of the same thing with this, is like what it actually learns is sometimes things you don't expect. My guess is that it would probably work. It would just like do weird shape shifting where like the art would change like positions, but the white background would probably be the same, or the cube might change slightly. It's just hard to say until you actually like do it and find out what you get. So that's a case where you might also want to just, so what Yadam was talking about, which is that like Runway has a StyleGAN 2 model now, and you can use their I think it's one free training. Is that right? You get one free training when you set up an account. So you could just like quickly throw your images into that. They have like a cropping tool that automatically crops everything for you. And you can actually do different types of crops. So you just throw it at that, and it'll take like the way that it trains relatively quickly. It trains in like a couple hours. So you could just try it and see if like, did I like this? And if I like it, then I might go back and like customize how it's training. But you might get a good idea. Yeah.
And is there a cap on when it's like a free training? Like, is there a cap on how many images they put into it? I assume
there's not a cap on how many images you put into it. There's a cap on how long it trains for. It trains for what is 3,000 iterations, which ends up being, I don't know what that converts to actually in like the way that you train it.
I think you can change that in Runway. You can change 3,000 for that model.
But the free one.
You can change it, but then it starts to charge you. So like it's up to 3,000, and then it'll start to charge you. But again, it's like, if 3,000 is probably like, probably like $30-40. So it like will save you some money. So you could just train it for 5,000 and just sort of see what you get. I would say like Runway is good to just like quickly iterate and try things. But I would say if you really want to control stuff more, then you probably want to do it yourself in Paperspace.
Gotcha. Okay. Do you know of any other projects that are kind of like adjacent to that, or no?
I had a student last semester that trained it on, there's like a popular Instagram account that is all artwork. 1,000 somethings. You know what I'm talking about? I don't know. There's like a very popular like art Instagram account, and she scraped all of those images.
Yeah.
Now that was different because it wasn't in a space, but it did produce. I'll find the video that she posted of it.
Cool.
But it is pretty interesting. But it was a lot of soupiness. I would say like training on lots of different pieces of art where the art style is very different, it just doesn't learn a lot. So that's where it gets tricky, is like if you had thousands of images of all Renaissance artwork in white cubes, like then it would learn Renaissance artwork and white cubes. But if you throw it just sort of any type of artwork, like pop, Renaissance, like anything else, it's just going to be like
more than $50,000 on this artwork. It's
yeah, it's just going to learn. It's going to learn all sorts of weird stuff, and mostly just be noise and texture, which is still a cool idea, but it's just different. Yeah,
I would be curious to see that. That sounds awesome.
Yeah, I'll definitely share it with you. I think it might be in our Slack channel. It's just like in a different channel that I can find and link to for you.
Cool.
For the fruit stickers, how many images were in that data set?
It was interesting. I mean, I had about 1,000, but some of them were too small. So I actually, you had a section, Derek, in the image tools script that had a pad function around it. Mm-hmm. So instead of the crop to square thing. So I found that and fixed that up so that the ones that were too small would at least have more of a white background. Also, I've been meaning to send you a PR for that, but we'll see if I have the time.
Cool, sounds good.
Yeah, so I ended up with about 1,000, but I also rotated them. So it was both the vertical ones, then rotated 90 degrees, 120 and 270, and flipped horizontally. So I used the reflect, whatever.
And that was after you collected 1,000, you did all that?
Yeah, so I ended up with probably 8,000 images.
Oh, wow.
And that makes sense because that's probably why your text got eviscerated, because it just like, it never learned that like, you did so many manipulations to sort of the labels that it generally sort of like learned shapes and colors and some structure, but yeah, and that's fine. That's totally reasonable to do. Some other people might decide I only want to look at it not flipped or not reflected, so maybe it learns the text better, and that's also an option. Although in general, I've just found that like these models never learn text that well. Although Kirk, yours is an exception. It's like because yours are individual letters, it might learn that. Whereas like if it's just a piece of text, it never learns a piece of text, like a sentence or other things written out. It never learns those very well just because of, I think it's like such a small piece and it's like manipulated often in many different ways. So yeah, there's many different reasons for why that is.
And that was StyleGAN, right? The free stickers.
Okay.
Yep.
Yeah.
Cool. Thanks.
Cool. Anyone else want to talk about what they're working on?
I'm planning to create a new data set. But I remember that at the beginning of the course you mentioned that you can create for me this script to generate images from Illustrator.
Yeah.
Because I'm using vectors this time.
Yep.
So is that possible, or can we discuss that?
Yeah, I mean, if you send me what you want, I could like bring a script in Illustrator is like not like, I can usually do it in like an hour. Just send me what you want and we can look at making it. And like, I'm happy to make tools like that for people because I'm sure there will be other people in class, either in this class or other classes, that are also interested in that sort of thing. So that's definitely something that's possible. Just like what I generally need to know is like, what do you want to do? And like, how are your pages set up so that I can like actually structure it? Because basically what you do is you end up writing, of all things, you end up writing JavaScript and Illustrator to like manipulate things. It just, I know how it works. It just takes a little bit of time to like play with. So yeah, so that's possible. Just let me know what you're interested in and we can try to make it work. It might not happen in the next week, but I could definitely get it to you by the end of class. So like you can use it at some point.
Got it. Basically what I have is a huge file in Illustrator with a lot of vectors. The shapes are pretty similar, but my problem is how can I generate these 1,000 images, you know, out of that file? It's one artwork space.
Yeah, the trick there is we would need them to either be grouped or we would need them on individual artboards. So that's like probably the work that you would have to do. Because there's no way that I could just like guess what is a group or what isn't. So that's what we'd have to figure out, and we could try to figure that out together.
Okay, got it. But that means that I have to create 1,000 artworks.
Probably, yeah. I mean, again, if you've made 250 and you're okay with rotating them, we could just like you could generate 250 and then rotate all of them, and then you would get 1,000 that way.
Got it.
So yeah.
Well, I have time now, so.
Shut in, out of a job. Yeah, this is like, sorry, this is, I don't want to make fun of your like,
no,
sucks,
do
like,
it.
Yeah.
Okay.
No, but no, and I don't even want to make fun of it. I'm just saying like, yeah, you do have time. It is a real thing. So yeah.
Oh yeah, absolutely. Yeah.
Cool. All right, well, if no one has anything else, we can finish 5 minutes early. You can go back to hang out in your apartment again. And then, yeah, just like, please reach out to me on Slack if you have any questions for anything. I'm happy to work with people. I'm also happy if you like want to set up like a 20-minute session, like middle of the week, just like let me know. I'm also hanging out at my apartment all day. So I'm happy to like set up little sessions to talk to people. So yeah, just let me know whatever needs. I'm happy to work with people as needed. And we can find a flexible time for everyone's schedule. So thanks everybody. So next week we will do like, again, hopefully come with things that you want to talk about. And I'll work through everyone's work. And then depending on how much time we have left, I might do some other demos or work through some other things to talk about. So maybe I'll save like half an hour for the end of class to walk through some things. But yeah, definitely just come with stuff and like we'll find things to talk about.
Cool.
Cool. All right.
Thank you.
Thanks so much, everybody.
you.
Stay safe, wash your hands, all those sort of things.
Take care.
Bye.
Bye.
Bye-bye.
See you, everybody.
Bye.